in this video, I'm going to solve, I'm going to go through the practice test that we did in class on Thursday. And so this is the practice test. We have the answer sheet. The PDF of this is available on Canvas. For question 1, this is in figure 1. What is the y component of force A in pounds? So y component of force A. Use a negative sign if it's in the negative y direction. All right, so A is the one that's pointed down and to the right. So what the y component of that, so A in the y direction equals that 14 pounds times cosine of 38 degrees, and it's in the negative direction. So cosine, because we have SOHCAHTOA, we have an angle here, we're interested in the adjacent side. So that's why it's cosine, and then it's pointed in the negative direction, in the negative y direction, which is why we know it's negative. So AY equals, grab my calculator. Sorry. 14 times cosine of 38. We get 11.03 pounds. I'm just going to put a box around it. In figure 1, what is the x component of force B in pounds? Oh, I forgot the negative sign there. Negative 11.03. In figure 1, what is the x component of force B in pounds? So the x component of B. And it would be 20 pounds times, and then 5 over 13. That would be the x component. So 20 times 5 divided by 13. So we get the x component is 7.69 pounds. I'm actually going to erase the little half of that. So I'm going to go back up to the answer sheet and just put in the answers. So it tells you that they asked for what is the y component in pounds, so we can just write negative 11.0 or 0.03. And then for number 2, it was 7.69 pounds, and that is in the positive x direction. So 7.69. Now question 3, if the resultant force is 200 pounds to the right, and F1 is 705I minus 550J, what is the magnitude of the force F2 in pounds? So the resultant force, let's draw this. The resultant force is 200 pounds to the right. And F1 is 705I minus 550J. And then we wanted to find what F2 is, and we don't know anything about F2. And we want to know the magnitude of F2. So we can do it a couple of different ways. We could actually visually add our, let's see, we have R equals F1 plus F2, and we could rearrange that to R minus F1 equals F2. And so we can visually do R from tail to head minus F2, so that would be the negative version of this. So that would go back in this direction. And then that equals F1, which would be here. So I could do that with a triangle. The other way to do it is just like we've been doing, where we break it into component forces. Sorry, I'm having trouble. Let's see. Sorry about that. I'm having some issues with my computer. If we do it the component version, so F1 is the 705I, 705I minus 550J plus F2 in the X direction, I plus F2 in the Y direction, J, and that equals, and then R, we need to write in I and J, which would just be 200 I and then 0 J, because they would know it's to the right, 200. So F2X I plus F2Y J equals, and that'll be 200 minus the 505, or minus 705I, so negative 505I plus 550J. So that means they want to know what the magnitude of the force is. So this will be F2 equals that. The magnitude of the force of F2 equals the square root of 505 squared plus 550 squared. And to do that really quickly on a calculator. You get 746.7 pounds. So that's that. It says the resultant force for the next problem 4, the resultant force for problem is K equals 910I plus 376J. Determine the direction of the resultant force measured in degrees counterclockwise from the positive x-axis. So I think for this one I would do the same where I draw it out. So X, Y, and it's 910I plus 376J. That force. So that's that K. They want us to find the direction of the resultant force measured in degrees counterclockwise. So counterclockwise goes like in the opposite direction that the numbers on a clock go. So that would be in this direction from the positive x-axis. So we want to find that theta there. So tangent of theta is going to equal, so tangent, we do SOHCAHTOA is opposite. SOHCAHTOA. So tangent of theta is opposite, which would be that 376 over 910. Opposite over adjacent. So theta equals, so the inverse tangent of 376 divided by 910. We get 22.4 degrees. So I'll go back and write those up. So question 3 was 746.7. And then question 4 is that 22.4 degrees. All right, question 5. In figure 2, what is a positive vector, the position vector r from A to B in meters? Express the answer in Cartesian vector form. So the position vector from A to B equals, and what I do is I just start at this point A, and then I figure out what I need to do to get to that point B. So the position vector, I need to go down 6 meters in the z direction, so negative 6k. So I go down to there, and then I need to go, let's see, 3 meters in the x direction, right? So plus 3I, this positive direction, and then we need to go in this direction to get to B, and that would be so in the negative j direction, minus 4j, and that's meters. Typically with Cartesian vectors, we'll put it in the order of I, j, k, so I'm going to do 3I minus 4j minus 6k. although that above one would be correct also. So that's the answer to that one. So I'm going to box it. I might go ahead and write it at the top. 3i minus 4j minus 6k. So I'd be really careful, check to make sure you wrote it right. So 3i minus 4j minus 6k. And you found out in the test, I'll mark it wrong if it's just a negative sign is off, if anything's wrong about it. So the unit vector from A to B. So the unit vector from A to B equals the position vector divided by the length of the position vector. So the position vectors that are 3i minus 4j minus 6k, that's meters, and then divided by the length of that, which would be the square root of 3 squared plus 4 squared plus 6 squared. That's meters also, so the meters cancel out, which is good for a unit vector. So just calculating that out. So it's basically the square root of 61 on the bottom. Let's see. Which is 7.81. And so it's 3 divided by that 7.81. So that's 0.38i minus, and then 4 divided by that 7.81, which is 0.51j, and then minus, and then 6 divided by that 7.81, which is 0.77k. Now we'll write that up at the top. So 0.38i minus 0.51j minus 0.77k. All right, now we're on to number 7. The unit vector is negative 4/7 I plus 1/7 j minus 6/7 k. If you know the magnitude of the force FCD is 200 newtons, what is FCD in newtons? So FCD equals the magnitude of FCD times that unit vector from C to D. So that's going to be 200 newtons times negative 4/7I plus 1/7j minus 6/7k. And so that we get negative 114I plus 28.6j minus 171k. That's in newtons. And they asked us to express the answer in Cartesian vector form, and they asked what it is in newtons. So we can just write this part of it on the answer sheet, but if you add newtons, that's fine too. So negative 114I plus 28.6j minus 171k. So that's number 7. Let's go down to number 8. So we're getting those 3D ones. We want to know what the x component of the force F1 is in newtons. So this one's F1. So the x component, so this is the transverse and azimuth. So F1 of x is going to equal, so we have that 150 newtons, and so we're going to basically get it up to that F1 prime. So F1 prime. And that's going to be 150 times cosine of 35. So we're just looking at this little triangle here. So 150 newtons times cosine of 35 degrees. And that gets us up to that F1 prime, and then we need to get over to that x-axis because that's for the x component. And so then that would be sine of 25 times sine of 25 degrees. because we don't want the cosine would be this y-axis. We want the x-axis, or the x component, so then that would be sine of 25. So then we multiply that out. 150 times cosine of 35 times sine of 25. We get 51.9 newtons. It says use a negative sign if it's in the negative x direction. You can see from the drawing up here that F1 is pointed towards the positive x direction, so it is positive just as a check. So it's 51.9. Write that on the front. Sorry for the jumping back and forth. And then problem 9 is using that same figure. What is the y component of the force, F2? In newtons, use a negative sign if the force is in the negative y direction. So F2, so this is one where they give us the angle to each of the axes. So for this F2, we're just going to look at this triangle here. And so F2 in the y component is just going to equal that 300 newtons times cosine of 45 degrees, because it's that adjacent side to that angle. So 300 times cosine of 45 is 212 newtons, and that is in the positive y direction. So 212. Write the answer in. And now question 10. If m equals 353I minus 251J minus 458K newtons, and n equals 97I plus 107J plus 153K newtons, what is the resultant force R of m and n? So R equals m plus n. R equals, so we're just adding this, so 353 plus 97. I'm just taking off both of these I components. Plus negative 251, so here's the J's, plus 107 in the J direction, and then plus negative 458 plus 53 in the K direction. And that's newtons. So just add those up. Now notice I didn't put the whole thing in there, so you have to be careful when you enter stuff into the calculator. 450I minus 144J minus, let's see, 458. So get me this calculator, plus 53. So negative 458 plus 53 is negative 405K. That's all in newtons. So that was pretty simple. Let's see. Go ahead and write that up at the top. So it's 450I minus 144J minus 405K. We don't have to write newtons because it asks for it in newtons. And then for question 11, it actually didn't ask for it, but in the test I'm not going to require you to write the units. Question 11, if W equals 43.8I minus 56.6J minus 48.2K pounds, what is the coordinate direction angle alpha, that's what we're asking for, of the resultant force W in degrees? So for those coordinate direction angles. See where alpha is to the x-axis. So cosine of alpha equals the w of x over w. So the w of x is that x component of the w, and then we divide that by the magnitude of w. So w is going to equal the square root of 43.8 squared plus 56.6 squared plus 48.2 squared. And so w equals 86.29, that's pounds. And so alpha is going to equal, and the wx is just that 43.8. So the inverse cosine of positive 43.8 divided by 86.29. And that equals, so make sure you can do this. So and then you get 59.5 degrees. Is alpha. It just asks for alpha. And so that's it for me solving this. You'll see I just went through it and I solved each of them. This we didn't have to do. But I solved each of them. What I would do now if I were actually a student taking the test is I would go back through and just check all my calculations and everything, especially if I had time. So say it's, I don't know, say it's 3:30 or something, you still have 45 more minutes. I would go through and check each of these just for, silly calculation mistakes. So actually enter back in the calculator, make sure I'm answering what they're asking for, make sure I got the signs right. I'll go through and check them all. And then I would go up to the front and get them checked. And then remember, if anything's wrong, if like a negative sign is wrong or something, then it's just wrong. And so go back and just check carefully when you miss any of those, so you can get it right on attempt 2. All right, that's it.